An overview of the scope. It's a 24-inch Ritchie Creighton. It's on a fork mount, but it's a single arm, custom design about in 1990, I think. I had planned on unwrapping the whole thing to show the whole thing, but I'm the only one here at the moment, and it's a two-person job to get it wrapped again, so I won't be able to do that. Just to give you a little scale, that's a 5-foot ladder. That's an 8-inch finder scope. And the long refractor is a 7-inch astrophysics refractor. So it looks pretty small against the tube because the tube is extremely large and heavy. The tube is 400 to 500 pounds by itself, and then with the mount arm and so forth, it's about a ton, 2,000 pounds. So it is a beast. It was used to find asteroids in the Kuiper Belt in the early 90s. And then you can see the old school ST4 with an RS-232 interface as a guider with an off-axis guider, custom off-axis guider. And that little circle there is so you can change out the secondary to a different F rating. I think it's 13.2. I may be wrong on that. It's 13 point something. Right now it's F7, so or F7.5, I think. But anyway, that allows you to do that, and the mirror's around here somewhere. Right now I'm just trying to get a way to make the electronics work because they're 29 years old, and I need to be able to use this remotely. The actual observatory that's in is a ash dome. It's powered by a computer, but it's a 386 computer. Those are the flats that you calibrate against this particular scope, since you can't have a flat box on it. And you can see that the dome lights, there's the motor, but the dome lights themselves. There's the control room, and a temperature controlled control room that is separate from this area so that the scope, so you can be warm and toasty while the scope is same temperatures outside. You'll notice here that the dome's controls have dimmers, which is really nice, especially when you're creating flats. And also just to work. So, this is the right ascension assembly. This is the east side with the reduction gears. Here is the Eddie Byers worm gear, 20 inches, 20 teeth. The electronics driving it, that 25-pin cable runs down to computer room. You notice how filthy it is inside because moths have lived their lifespan out here because it's not been in use for so long. I don't know what those two boxes there are with various connections. They say they're 12-volt, 1-amp boxes, dual boxes. Little concerning is a couple of cables hanging down there. I don't know if you can see them. Looks like it goes to a cable, and they're just hanging there. I don't want to make them touch metal or anything because I don't know if they have current, but anyway, I'll go little orange cables, and they're green and black and white. See if we can get the little circuit board pinouts there. Again, below this, there's these two cables hanging down. You can see them, but There they are. Okay, there are the hanging cables that I couldn't get in the first video. And they're going to an orange cable that is very similar to that orange cable, which is a power cable, and it may be that cable that wraps around here in the harness. But again, the most concerning part is they're just bare cables right there, just hanging there. So I'm not sure what that's about. Hopefully we'll figure it out. Here is the west side of the right ascension gear system. Those are reduction gears. And this is the inside on the west side. There's a hole in the way, obviously. But you can see all the dead moths. So I'm trying to vacuum out, but I also don't want to damage any electronics. And you can see those two boxes over there, which I mentioned before, but they're a little more visible here. And that PVC tube goes down to the control room. And that goes up the fork arm. This pole goes up the fork arm. It's a single fork arm. You can see it here on what the scope is mounted on. And I'll pan around here. And I've got the cover off of the deck gear as well. These are weights to help balance. You'll see them on the front and there, on the tubes, on the tube. There is the deck gear system. That is a custom stainless steel gear, 360 tooth, and approximately 17 inches. These are top and bottom gears here. And those are American Precision Instruments stepper motors. There's the bottom one. Give you a little bit of scale. There's my hand on the gear. Then pan out to the telescope. And back to the deck gear. If we go inside the fork, you can see how it goes into the whole DOTA. And that goes down into the electronics that we just looked at. And another panel for which there's a multimeter hooked up to it, so I'm not really sure what the purpose of it was for. And this goes to another device down here or somewhere. Let's see here. Oh, let's see. That's just a serial connection to the S-Big. Maybe there was some addition for the electronics to help send pulses to it or something. To help track for auto guiding, maybe? I don't know. It has a different auto guider on it, ST4 it looks like. There. And again, just to give a sense of scale, that's my hand on the back of the telescope. Information here. If you notice on the Eddie Byers gear, there's some strings wrapped around it, and those strings ultimately wind down into these weights in these PVC tubes. And these are probably 15, 20 pounds each with the feel of it. And from what I understand, they keep tension on the gear and the worm gear and the worm wheel to prevent or mitigate at least backlash.